Welcome to our 27th lecture on quantum mechanics. Today's topic is problems from infinite potential well. Quantum mechanics 27 problems. Problems from infinite square well potential or particle in a box. The first problem I shall read. For an electron in a one-dimensional infinite potential well of width 1 angstrom, calculate 1, the separation between two lowest energy levels. 2, the frequency and wavelength of the photon corresponding to a transition between these two levels. And 3, in what region of the electromagnetic spectrum is this frequency? That's the question. അപ്പോൾ ഇലക്ട്രോൺ ഒരു വൺ ഡയമെൻഷണൽ ഇൻഫിനിറ്റ് പൊട്ടൻഷ്യൽ വെല്ലാണ്, ബോക്സ് ആണ്, വിഡ്ത്ത് 1 ആങ്സ്ട്രോം. കാൽക്കുലേറ്റ് ദി സെപ്പറേഷൻ ബിറ്റ്വീൻ ടു ലോവസ്റ്റ് എനർജി ലെവൽസ്. താഴെയുള്ള രണ്ട് എനർജി ലെവൽ ഉണ്ടല്ലോ, E1 E2, അവ തമ്മിലുള്ള വ്യത്യാസം കണ്ടുപിടിക്കണം. രണ്ടാമത്തത് ദ ഫ്രീക്വൻസി ആൻഡ് വേവ് ലെങ്ത് ഓഫ് ദി ഫോട്ടോൺ കറസ്പോണ്ടിങ് ടു ട്രാൻസിഷൻ. ഈ സെക്കൻഡ് ലെവലിൽ നിന്ന് ഫസ്റ്റിലേക്ക് ഒരു ഇലക്ട്രോൺ ട്രാൻസിഷൻ ഉണ്ടാകുകയാണെങ്കിൽ അതിൻ്റെ കറസ്പോണ്ടിങ് ഫ്രീക്വൻസി കാരണം. മാത്രമല്ല ഈ റേഡിയേഷൻ, ഈ ലൈൻ, ഈ ഫോട്ടോൺ ഏത് റീജിയനിൽ, അതായത് വയലറ്റ് ആണോ ഇൻഫ്രാറെഡ് ആണോ എന്നൊക്കെ കണ്ടുപിടിക്കണം. അതിൻ്റെ ഫ്രീക്വൻസിയും കണ്ടുപിടിക്കണം. Read it again. For an electron in a one-dimensional infinite potential well of side 1 angstrom, calculate 1, the separation between two lowest energy levels. 2, the frequency and wavelength of the photon corresponding to a transition between them are these two levels. And 3, in what region of the electromagnetic spectrum is this frequency? So you remember particle in a box, the infinite square well potential, the energy of the particle we have seen E or En, pi square h cut square n square by 8m square, where 2i is the, 2i is the width of the well and n is the quantum number. Width of the well is 2, remember. So for the first ground level, first level n is 1, therefore E1 is equal to 1 square, n square 1 square, pi square h cut square by 8m square. That is pi square h cut square by 8m square. For a second level, n is 2, therefore we get U2 is equal to 4. N square is 2 square 4. U2 is 4 pi square h cut square by 8m square. So next step is separation. Separation between the two levels, energy levels, the first level and second level, that we mark as delta E. ആ രണ്ട് ലെവൽ തമ്മിലുള്ള വ്യത്യാസത്തെ നമ്മൾ ഡെൽറ്റ ഇ എന്ന് വിളിക്കും. ദാറ്റ് ഈസ് ഡെൽറ്റ ഇ സി 2 മൈനസ് E1. ദാറ്റ് ഈസ് ഡെൽറ്റ ഇ സിക്കൽ 4 പൈ സ്ക്വയർ എച്ച് കട്ട് സ്ക്വയർ ബൈ 8m സ്ക്വയർ മൈനസ് 4 പൈ സ്ക്വയർ 4 പൈ സ്ക്വയർ എച്ച് കട്ട് സ്ക്വയർ ബൈ 8m സ്ക്വയർ ഈസിക്കൽ ടു 3 pi square h cut square by 8m square, because we have taken a common factor. 4 minus 1 is 3. 3 pi square h cut square 8m by 8m square. And given width of the well, 2a, 1 angstrom. That is 2a. 1 angstrom is converted into meter. So a is equal to 10 raised to minus 10 by 2. That is 0.5 into 10 raised to minus 10 meter. And that value we put to the equation. And h cut, h by 2 pi 1.055 into 10 raised to minus 34. And mass of electron, here particle is electron, mass is 9.1 into 10 raised to minus 31 kilogram. Therefore separation, 3 pi square h cut square by 8m square is equal to 3 into 3.14 square into 1.055 into 10 raised to minus 34 whole square all by 8 into 9.1 into 10 raised to minus 31 into 0.5 into 10 raised to minus 10 square. 0.5 angstrom is written like that. And that on calculation we get 1.812 into 10 raised to minus 17 joule. And we have to convert it into electron volt. So we write delta E is equal to 1.812 into 10 raised to minus 17 by 1.6 into 10 raised to minus 19. We get the answer 113.27 EV. And this is 3 times the ground level. You remember, this is 3 times delta E is 3 times the ground state energy. So the ground state energy usually will come as 37 or 37 point something, 37.7 in that order. This is 3 times ground state energy. Ground state energy is 37.7 EV. That we see the next problem. And here, the second part of the question is, what is the frequency of the photon emitted? If there is a transition for electron from the second state to first state level, what is the energy of frequency of photon emitted? And frequency is always we determine using the Planck's relation delta E, or E is h nu. Delta E in joule 1.812 into 10 raised to minus 17 is equal to h 6.626 into 10 raised to minus 34 into nu. So nu is equal to 1.812 into 10 raised to minus 17 by 6.626 into 10 raised to minus 34 is equal to 2.7 into 10 raised to 16 hertz. Corresponding wavelength lambda, you know, C is nu lambda, or lambda is C by nu 3 into 10 raised to 8 by 2.7 into 10 raised to 16 is equal to 1.1 into 10 raised to minus 8 meter. And you look what we are doing. Here frequency is given, and we have to say the region of the frequency. In which region of the electromagnetic spectrum this frequency, this photon is coming. And you know the region you have to remember, it is in the tables page 72. The frequency and the various regions are given. You read it, you refer the table. Tables can be used in the examination hall also. So when we study, when we refer that table, you look at the right side. 10 raised to 15 to 10 raised to 14 corresponds to hertz, corresponds to visible. And 10 raised to 15 to 10 raised to 17 corresponds to ultraviolet. In our question, the answer for frequency is 2.7 into 10 raised to 16. And that is coming in the UV region. You look, UV region 16, 15 and 17 in between. So ultraviolet, but ultraviolet region frequency is 10 to 15 to 70. Hence, the frequency obtained falls in the UV region. നിങ്ങൾ ഓർക്കണം, നമുക്ക് കിട്ടിയ ഫ്രീക്വൻസി ഫോട്ടോണിൻ്റെത് 2.7 into 10 to 16 ആണ്. നമ്മൾ ടേബിൾസ് നോക്കിയാൽ അവിടെ ഇലക്ട്രോമാഗ്നറ്റിക് സ്പെക്ട്രത്തിൻ്റെ എല്ലാ വേവ് ലെങ്തും, എക്സ്റേ, ഗാമാറേ, അൾട്രാവയലറ്റ് എല്ലാത്തിൻ്റെ വേവ് ലെങ്തും ഉണ്ട്, എല്ലാത്തിൻ്റെ ഫ്രീക്വൻസി ഉണ്ട്. വിസിബിളിൻ്റെ ഫ്രീക്വൻസി കൊടുത്തിരിക്കുന്നത് 10⁻15ൻ്റെയും 10⁻14 ഇടയ്ക്കാണ്. നോക്കിയാൽ കാണാം ടേബിൾസ് പരീക്ഷ ഹാളിൽ നോക്കാവുന്നതാണ്. പിന്നെ അൾട്രാവയലറ്റ് നോക്കുകയാണെങ്കിൽ അത് 10⁻15ൻ്റെയും 10⁻7ൻ്റെ ഇടയ്ക്കാണ്. നമ്മുടെ ഈ ചോദ്യത്തിന് ക്വസ്റ്റിന് ഉത്തരമായിട്ട് കിട്ടിയ ഫ്രീക്വൻസി 2.7 into 10 to 16 ആണ്. ആ 2.7 5ൽ കുറവായതുകൊണ്ട് ഒന്നും എടുക്കുക. അപ്പോൾ 10⁻16 ഹെർട്സ് എന്നുള്ള ഓർഡറിലാണ് നമുക്ക് ഫ്രീക്വൻസി കിട്ടിയത്. ആ ഫ്രീക്വൻസി ഇവിടെ ഷൂട്ടാകുന്നത് അൾട്രാവയലറ്റിലാണ്. അതുകൊണ്ട് പറയും നമ്മുടെ ഫ്രീക്വൻസി, നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്ത ഫ്രീക്വൻസി വരുന്നത് അൾട്രാവയലറ്റ് റീജിയനിലാണ് എന്ന്. Now comes another important question. You have to carefully note it. Question number 2. Find the least energy of an electron moving in one dimension in an infinite potential box of width 1 angstrom. M Here it is particle is electron. Me 9.11 into 10 raised to minus 31. Exact mass is given. H is also given. And remember, the box can be considered in two ways. That is 0 to L length or minus A to plus A length. In that case, L is equal to two-way. If we put the potential barrier as minus A to plus A, the total distance is two-way. Therefore, L can be written as two-way. The two form of writing the formula is given here. That is, if we consider the box as one of length L, the formula becomes En is n square h square by 8 ml square. Or if we put L as two-way, then the formula becomes pi square n square h cut to square by 8 ma square. That is the formula we have studied. And that is equivalent to the formula we have written in front. If you check, you can see that this formula gives the same idea because L is two-way. You put a two-way in the place of A, the second equation. In the place of A, you put L by 2. Then h cut we have to write as h by 4 pi. H by 4 pi square. Pi square cancels. 4 cancels. We get the first equation. You understand the formula? Both are same. If we put 2a as L, A is L by 2. Put here in the equation. In the place of A square, we write L by 2 square. A4 coming in the denominator. H cut is h by 2 pi. 4 pi square is coming. Pi square cancel. 4 cancel. You will hear the first formula we get n square h square by 8 ml square. So when you write as L square, in the numerator there is h square, no h cut, and there is no pi. If we write L as two-way, in the numerator there is h cut square and also pi square. I think it is clear. In the first term, there is h. In the second term, there is h cut. So when you write h cut, to compensate it, we have to write a pi square. And A and L are related by the manner L is two-way. So you carefully remember. And you also know the corresponding wave function. For the first expression, we use the wave function psi is equal to root of 2 by L. That is the normalization constant. Root of 2 by L psi n by x by L. And for the second eigenvalue expression, we write the wave function psi is 1 by root a sine n by x by 2a. Both are same. You remember, for first expression, the wave function is psi is equal to root of 2 by L sine n by x by L. For the second expression, the wave function we write the manner psi is 1 by root a, small a, 1 by root a sine n by x by 2a. That we have seen in one of the problems previously done. So the ground state energy we are calculating. You can use any formula. Here we have calculated using L. That is N is 1, H is given, M is given, N is given. Ground state energy 1 into n square 1 into 0.63 into 10 raised to minus 34 square by 8 into 9.11 into 10 raised to minus 31 into 10 raised to minus 10 square, 6.03 into 10 raised to minus 18 joule, convert into EV, we get 37.69 EV or 37.7 EV. And when we do this problem using the second expression, that is pi square n square h cut to square by 8 ma square, we have to write n is 1, h cut is 1.055 into 10 raised to minus 34, and A, the given distance 1 angstrom, that you take as 2A, and therefore A is 0.5 angstrom. In the place of A, you have to put 0.5 angstrom. Then we get the same answer. The first formula you can use, as we have seen here, or second formula you can use. when we use second formula, in the place of a, small a, you have to write 1 by 2 angstrom in meter, convert into meter. It's got to, you know. You can do it as a homework. And so the ground state energy in a 1 angstrom box is 37.7 eV. Next problem. A particle is moving in one-dimensional potential box of width 25 angstrom. Calculate the probability of finding the particle within an interval of 5 angstrom at the center of the box. What is when it is in the least energy state? Least energy state is the ground state, and the particle is in the middle of the box. We have to find the probability. To find the probability P, we have probability W. We have to find the first probability density. So to find the probability density, we have to remember the wave function. Here particle in the ground state. So the wave function becomes root of 2 by L sin n pi x by L. That can be written as pi by L x. N is 1. You remember that we read as sin n pi by L into x. X is the numerator. For ground state n is 1. So psi x is equal to root of 2 by L sin n 1 pi x by L. Here x is L by 2. We have to find the probability in the middle of the box. So in the place of x, we put L by 2. We get to the value root of 2 by L sin pi by 2. Sin pi by 2 is 1 root of 2 by L. Probability of finding the particle in the interval at the center of the box. That is probability density. You have to write as probability density, not the probability density in the middle of the box. Probability density, probability per unit interval is the probability density. That is psi star psi, or psi modulus square. Psi modulus square, that is root of 2 by L square, 2 by L. That is P, the probability density. The symbol is differently used here. The first term is P. Now probability in an interval of delta x is 5 angstrom. That is in the place of P, we can write W. As our lecture note, we have written as W. Here it is P. You write P as probability density in the above step, and the last step you write as W. W is equal to P into distance. Probability density at the center into distance. Distance is given 5 angstrom. So 2 by L into delta x, that is 2 by 25. Length of the box is 25 into 5. That is 0.4. That is probability density. It has no specific unit. Now we consider an eigenvalue problem. And similar problem we study when we study in detail the eigenvalue equations. Determine the momentum eigenvalue of the wave function psi is equal to a e raised to ikx. And this we have seen, this function we have seen in free particle. It is the free particle wave function. അപ്പോൾ ഇതിൻ്റെ മൊമെൻറ്റം ഐഗൻ വാല്യൂ കണ്ടുപിടിക്കണം. ഈ ഫംഗ്ഷൻ്റെ മൊമെൻ്റ് ഐഗൻ വാല്യൂ. അല്ലെങ്കിൽ the eigenvalue equation is a psi is a psi, h psi is e psi എന്ന് പറയുന്ന പോലെ. A psi is a psi, a is the operator and small I is the eigenvalue, where small I is the eigenvalue. The momentum operator is a is equal to I h dou by dou x. So the above eigenvalue equation, we write a psi equal to small a psi, we write I h dou by dou x psi is equal to I h dou by dou x. We give the value of psi, a e raised to ikx. When we differentiate, we get I h into, when we differentiate an exponential term, a will come out. A will come out, and or we can write a we can keep inside. Ik is taken out. Ik is taken out. The function is repeated. Dou by dou x of a e raised to ikx. That's a derivative. You verify the derivative. IH cut is constant. When we differentiate exponential function, the constant in the power will come in front. The function is repeated. And that is repeated function we write as psi. So we get minus the operator is a minus. You remember the moment operator is minus IH dou by dou x. Moment operator is minus IH. You have to put to minus. The moment operator A is equal to, it is minus IH dou by dou x. Remember. So that minus is here. Minus IH cut into IK, that is minus I square H cut to K. The remaining is psi. The function is, that is differentiated. On differentiation we get IK, there's a correction. You look here, when we differentiate, we get IK in front. Then the remaining is dou by dou x of psi. So, the LHS becomes IH cut dou psi by dou x is equal to IH cut k psi. When we differentiate that dou by dou x, once differentiated, dou by dou x can be removed. Dou by dou x is not required. When we write ik in front, dou by dou x can be removed. We get a raised to ikx. Dou by dou x is not needed. The result is minus I square h cut k psi. So, the eigenvalue equation becomes IH cut dou psi by dou x is equal to 1 minus I square is plus 1. H cut k psi. Compare with 1. First equation, Si is Si. Equation number 1, Si is Si. Compare with 1, we get A is H cut K. A is H cut K. So you remove the confusion. When we differentiate IH dou psi by dou t, the answer is minus I square H cut K psi. Before that final answer, I have written dou by dou x. That is a mistake. Dou by dou x is not needed. When we differentiate the function, we get ik a e raised to h cut e raised to kx. That is I square h cut k psi. So in the second term of differentiation, dou by dou x is repeated. That is not needed. I think it is clear. You know, it's a simple differentiation. So that is all with our 27th lecture on quantum mechanics. The next class we come with another topic. Thank you very much.